C, and it will be a rate of 1.75 compounded monthly. So what we need to find is which bank offers the highest APY, or the highest effective rate, which is R sub E. So we start with the first bank, and for this one we're going to use R is equal to 0.0180. T will equal to 1 because we're talking about the APY, 1 year. However, the compounded periods will be for this one annually, so it will also be 1. So to find the, recall the formula is to find R sub E, and we get that formula from here. That would be 1 plus R over M to the power M, and then minus 1. So for bank A, we'll have 1 plus 0.0180 divided by 1, parentheses, close parentheses again, to the power 1 minus 1. And so that will give us the effective rate of 0.0180, which as a percent will be 1.80. So now let's compare that to bank B. So in this case, the rate is 1.77 or 0.0177, and this is compounded quarterly, so M equals 4. So the effective rate for that will equal to 1 plus, parentheses again, 0.0177 divided by 4, close parentheses again, and then as the exponent, we use the number 4. Then remember, you have to get out of the exponent with the right side arrow, and then type in minus 1. So that will give you approximately 0.0178, and that will be 1.78%. Finally, for the third bank, bank C, the rate is 0.0175, and the M, number of compounded period, is 12 for monthly. So the effective rate at that bank will be parentheses 1 plus, open parentheses again, 0.0175 divided by 12, close parentheses again, to the power 12 for monthly, and then we get out of the parentheses and we need minus 1, and that will give us approximately 0.0176, which it is 1.76%. So to answer this question, which bank offers the highest APY, the answer is obviously the first one, Bank A, with an APY of 1.80%. So now we're going to move on to the next topic, and this is present value for compound interest. And for this questions, we're going to be using this formula. Now recall that formula, it is the same as the following. Because we established that I is equal to R over M, and we also established how N is equal to M times T. So now if we take this formula here Well, for the next problems, we will be assuming that the interest will be compounded, well, actually just for problem 11, it will be annually. So we could use this formula here, and what I'm going to do is solve for present value. So if we have future value is equal to present value, open parentheses, and then we're going to have 1 plus I parentheses to the power m. And remember, what we are solving here for is, well, the question says what amount deposited today, so we're going to be solving for that present value. That is our question. So if I want to solve for present value, what I will do is I will leave future value on the left side, and then I will take this whole quantity here that is multiplying to the present value across the equal sign. So on the left side, it will be dividing. And this looks similar to a formula to find the present value of simple interest, section 5.1. So for that formula, we had future value divided by 1 plus R. Or 1 plus RT. Yeah. So that was section 5.1. Don't use that one today. So here our rate is 0.062, and our time is going to be here 5 years. So the future value in this case is going to equal to 6,000. So we want to know how much money will we have to deposit today, so that in 5 years we have $6,000 at an interest of 6.2 compounded annually for 5 years. So I'm going to substitute future value divided by 1 plus, in this case, I, since it is R over M, and we're talking about annual compounded interest, we will just have 0.062 divided by 1. So we could say that I is equal to 0.062. And here the power n will be mt. So it will be 1 for m because we have compounded annually, and 5 for t. So in this case, the exponent will be a 5, and that is our present value. So by typing this on the calculator, you will obtain $4,441 with 49 cents. And so that will be the answer to the question. Now we have here the same formula that we derived on the previous example. That formula is exactly the same as this one. The only difference is that the denominator was taken, and so when that happened, the exponent became negative. Instead of positive n on the bottom, now that is on top as part of the numerator, the exponent is negative. So those two formulas are the same. And what I'm going to do first is calculate. Well, first let's read the problem. We have a 0 coupon bond with a face value of 15,000. So that will be the future value at a rate of 6%, so 0.06. The interest rate is compounded semi-annually, so that means M equals to 2. And the maturity of this loan, of this bond, is 9 years. So what is a fair price to pay for the bond today? So what we're looking for is for the present value. So the formula to find the present value will be the future value divided by 1 plus I to the power n. Now let's find what n will be, and remember n is m times t, so that will be in this case 2 times 9, which is 18. So that's what we're going to use for n. And for I, it is r divided by m, so that will be 0.06 divided by 2, because we are compounding semi-annually, so this will be 0.03. So those are the numbers that we're going to substitute here and here. And so here for future value, we're talking about a 0 coupon bond with a face value of 15,000, so that's what will go here. Divided by 1 plus, we found I over here, 0.03, and the exponent will be 18 because that is what we found here. So if we enter that on the calculator, you might need to use an extra set of parentheses here around the denominator. So that will give you approximately $8,810 with 91.9. Since we're rounding to the nearest cent, we're talking about money, we will say 8,810 with 92 cents. And that will be the answer to problem number 12. So that will be a fair price for a bond, a 0 coupon bond, that will be $15 in 9 years. Now the next problem of this section is also about finding the future value. The present value. And so we're going to be using the same formula, future value over 1 plus I to the power n. Or we could also use this formula, future value times, if I take this quantity here to the top, it will be the same, 1 plus I, but the difference will be, the exponent will be negative n. So we could use that one as well. So for this problem, we have that the inflation rate between the years 2012 and 2014 was 1.72%. How much did an item that sells for 1,000 in the early 2015? So that is what we're going to consider to be our future value, the one that will go here. Future value will be $1,000. And the rate that they're talking about is 1.72. So as a decimal will be 0.00172. And for inflation, we use annually for the number of compounding periods. And for time, we will be using 3. So using these two quantities, we could find n, which is m times t, and that will be 1 times 3, which is n equals 3. Remember, it's 1 times 3. So from here, we could also find I, which will be r over m, and that will be 0.00172 divided by 1 because it's inflation compounded annually. So we're simply going to use 0.00172. So if we enter all of that into our formula, or substitute 1,000 for future value divided by 1 plus 0.0172 to the power 3, and we will get $950 with 12 cents. And that will be the answer to the question. So for an item that in 2015 was 1,000